So basically, first lecture, which is about plastic material and the important 7 points, which is very important for the design engineer. If you are going to design the mold, right? So then it means then you should have knowledge about these 7 points. Why? Because these 7 points we have to ask to the customer. Okay, understood? Okay, first of all, tell me what is about the plastic material. Basically, we have to deal with the plastic material if we are designing the mold, right? So we have to deal with the plastic material. Tell me what is the basic definition of the plastic material. Tell me, anyone? Tell me. Came. Tell me. Hemant. Vijay. Anyone? What is the plastic material? Before start the mold design, before start the part design of any type of component, right? For a specific component, so we should have knowledge about the plastic material also, right?
Yes.
So what is the plastic material? What is plastic basically? So plastic is nothing but it is a group of material, either synthetic, it can be synthetic or the naturally occurring, right? So you can say that this is the basic thing, right? Plastic is nothing but plastic are the polymers, okay? Or polymers are nothing but polymer is the substance which is made up of many repeated units, which is made up of many repeated units, which is also known as monomers, right or wrong?
Yes.
Monomers, right? Okay, so this is known as plastic material. This is the basic definition if someone asks to you. So this is the basic definition, right? Okay, now if I'm talking about the plastic, if I'm categorize the plastic material, so there are two category of plastic material. One is thermoplastic and second one is thermoset. Please off the mic. If you have any question query, you can ask the question query by on the mic. Okay, please off the mic. Okay, so plastic has a two category, thermoplastic and the thermoset. Okay, if I'm asking about the thermoplastic, so can you name any four or the five thermoplastic material? Tell me. Can you give the name? PP, right? You have seen that, right or wrong? POM, ABS, right? Okay, PA, PVC. So this all are the, what is this? This is the thermoplastic material, right or wrong? Okay.
Yes.
You are taking class
Yes.
by mobile or the by the laptop?
By the laptop.
Laptop. So into the laptop, every plastic component which is made up of thermoplastic material. Is it clear? If you are taking the class by the phone, if I'm talking about the plastic material or the plastic component into the phone, so that will be the thermoplastic again, right?
Okay.
Understood?
Yes.
If you are using pen for note down anything, right? So it means it will be the thermoplastic. Okay, now as we know about the thermoplastic or the thermoset, but we have to deal with the thermoplastic material for the molding, for the injection molding purpose, right? Okay, why? Acha, thermoplastic material has another name which is known as engineering material. What is engineering material? Acha, what is the reason of that? Why its name is also known as engineering material? Tell me. You have to reply, right? If you reply, if you question, then it means you are learning.
Shaped to required size shape.
Yeah, basically it is used for the engineering purpose, right? And if I am talking about the thermoplastic or the main plastic material, so basically plastic material is replacing the other material. You can say that it is replacing the other materials component, right? For example, for example, somewhere using sheet metal component, but that sheet metal component will be replaced by the thermoplastic material in over few times, right?
Yes.
Understood?
Yes.
Okay, 1 minute. Arif. Okay. So all are here, right? All 6 members are here. So basically, okay, as we discussed, the plastic material has the two category. One is the thermoplastic and another one is thermoset material. So as I told you, okay, as I said, the thermoplastic material is used for the molding purpose, right? Thermoplastic material is used for the molding purpose. Acha, why it is used for the molding purpose? Why thermoset is not used? Tell me.
It can be reusable, thermoplastic. Thermoset cannot be reused.
Okay, so basically this is the recyclable material, you can say that, right? This is the recyclable material, right? Now we know about the thermoplastic or the thermoset material, we know about the polymer material, right? So basically now we will go for the molding. So see here, this is the basic molding process. See, 1 minute. See, see here, see in this GIF, what is happening here? Tell me.
We are pouring the material and
So basically you can say that, 1 minute, you can say that, for example, this is the polymer material and this is nothing but this is the adhesive material. Okay, adhesive material, this is the polymer material. Okay, combined and pushed by the plunger or the piston into the impression, or you can say that mold core and cavity, right? Okay,
yes.
so after cooling or after completing the process, you will get a ball, because it has a ball impression. That's why we will get the ball component from the die or from the core and cavity. So this is the basic type of molding process, right or wrong?
Yes.
So it has been developed. So this type of process, it has been developed during the Second World War time, right? This is a small history about that. The molding come from Second World War, right? From the Second World War. Okay, you understood about this, right? So here see, so as I told you about the difference, so what is the main difference between the thermoplastic and the thermoset? Thermoplastic can be melted repeatedly, है ना? But if I'm talking about the thermoset once shaped cannot be melted again. This is the basic difference. That's why we will deal with the thermoplastic material for the molding technology. Is it clear?
Clear.
Okay, this is the basic thing. Okay, every engineer we should have, if I'm talking about every mold design engineer, if you are learning mold design, so you should have knowledge about the basic thing, right? Which is very important, right? Remember one thing, if you are taking the lecture, right? Remember one thing, take a book or notebook, right? And take a pen and prepare the notes, please, right? Which is very important. Yeah, I will provide you recording lecture as well as I will provide you PDF study material also, but your notes is very important for you, right?
Yes.
Right?
Yes.
Like for example, if you have a 10th exam, like for example, if a student have 12th exam, so you have to prepare the notes, right? That's why you can prepare the very well, right? So similarly, you have to prepare the notes, which is very important for you if you are learning in a proper way, right? Okay.
Yes.
So here one is about the shrinkage value. Okay. Now, what is the meaning of shrinkage into the plastic or the any type of material? What is the meaning of that? What is the shrinkage factor? Now see here, for example, if I have a three type of material. See here, I have a three type of material. One is the polymer or the PP, right? What is the full form of PP? Tell me. If you are from the costing department, you will know about the full form of the PP material. Tell me. Polypropylene, right? Polypropylene.
Yeah.
It is the thermoplastic material, right? Or if we have aluminium material, right? Okay, if we have a MS material, which is the mild steel. So basically, if we apply the heat to all the material, so basically after a specific heat, it will be melted, right or wrong? It will be melted. Okay.
Yes.
So basically, if we take a vessel, and into the vessel, if we pour this material, for example, if we are pouring one time in MS, and if we are pouring aluminum in second time, and third time we will pouring the PP material. So basically, after pouring the material into this, first basically, so it will get the shape. This material will get the shape depending upon the vessel, right or wrong?
Correct.
It will take the shape. Okay, so basically during the solidification, if any material, for example, I'm talking about any material, during the solidification, it will get shrinkage, it will get shrink into the inner side. Okay, for example, if I have a vessel like this, and this is the you can say that this is the diameter of the vessel. For example, if the vessel diameter is about 200 mm, how much? 100 mm. I am talking about diameter, right? Okay, if you are pouring the PP material, PP material, then its diameter should be 100 mm after the solidification, right or wrong?
Correct.
Yes.
But you will not go, you will not get 100 mm. You will, maybe you will get 99 mm. So what is the reason is that? What is the reason of that? Because it will shrink into the volume. It will shrink into the volume during the solidification. That's why. Okay, so if I am talking about, for example, if the vessel diameter is about 200 mm, and you will get 99 mm after the solidification of this plastic material, so how much percentage it will shrink?
1%.
1%. Okay, so for example, this is the specific plastic, any plastic, right? This is the specific plastic, any plastic. So its a shrinkage value is about 1%. Is it clear? So if I want to get the 100 mm dimension, then what will be the diameter of the vessel? Tell me.
101.
101, right? So maybe you will get around 100 mm, not exact 100 mm, but you will get around 100 mm, plus or minus, you can say that, right? Within a tolerance.
Yeah.
Understood?
Yes.
So this factor is known as shrinkage value. So shrinkage value, we have to provided this shrinkage value into the component by the scale body to get the specific dimension within a tolerance. Okay, like for example, you have seen a few drawings. So for example, like 50 mm dimension. So 50 mm dimension you will get like a plus minus 0.1, right? So what is the meaning of that?
Yes.
It has a 200 micron limit. Okay. To how 200? 100 micron in plus and 100 micron in minus. So basically it has a 200 micron limit, right? So within this dimension, if we want to control this 50 mm dimension within this limit, so basically we have to provide the shrinkage value, right? Understood? Okay. So mold shrinkage is phenomenon where the volume of the molten plastic filled inside the cavity of the mold shrinking at the time as begin to cool, right, and solidifying. Okay. Typically, if I am talking about the shrinkage value, so its value is around 0.2 to 2%, but it is vary depending upon the plastic material. It will be vary depending upon the plastic material. This is just a range for all the plastic material, right?
Yeah.
Understood? Now, there are two type of shrinkage value. One is the symmetric, and second one is asymmetric. What is the meaning of symmetric and the asymmetric value? Symmetric means you can say that uniform in all direction, right? For example, if we have a component like this, okay, and here in this component only this dimension is critical, right? Okay. And if I'm talking about the other dimension, this dimension is not critical dimension. Okay, this is a rough dimension, you can say that, right? Okay, so for controlling this dimension, we have to provide asymmetric tolerance for this, for controlling this dimension or the diametrical, right or wrong?
Yes. Yes.
Okay, for example, if we have a component like this, like a soap case component. So if I'm talking about this soap case component, so there is is there any requirement for giving the tolerance, giving the shrinkage value to this component? Because there is no dimension which is critical into this component. There is no dimension which is critical. So there is a requirement or not? Tell me.
Yes, there is a requirement.
Why?
Wait.
For example, I have a component like this, and what is the function of this? This is the soap case, for example, right? What is
Yes.
this is the soap case, and we have to put the soap into this section, right?
Yes.
So we need a fitment for this, for between soap and this,
Yes, we need a fitment.
or why we need a
Shrinkage is
fitment?
too much. We cannot fit the soap inside.
Yes.
If the shrinkage is too.
But there is no requirement into the shrinkage, because we don't need to control any dimension into the component. That's why we will not require to give the shrinkage value there.
Okay.
Okay, for example, as I told you, this is the fitment portion. In this component, this is the fitment part, right? So that's why, for example, this is the female part, and one more part is like this is the male part. So basically, this portion will fit into this female portion, right? So that's why we need to control this dimension, both shaft and the hole, right?
Yes.
Okay.
Yes.
So that's why, okay, so symmetric dimension is nothing but if we have a component like this, and this is the y axis, this is the x axis, this is the z axis, this is z axis. So basically, if we have a component in center, and if we require dimension like this, for example, this is the 100 mm and this is the 100 mm, and we need a uniform, you can say that we have an open tolerance component, you can say that, right? So we say basically we can provide the symmetric shrinkage. And if we for example, if we need a specific dimension, if we need a control specific dimension into this component, into any type of specific component, then we need a symmetric dimension. Understood?
Yes.
Not quite understood or confused?
No, confused.
Confused? So
Yeah.
now you remember one thing, that asymmetric dimension is used for example, we have a component like this, and we have a lots of dimension here, we have lots of dimension. Or if we are trying to control a specific dimension, it means we are providing the you can say that other shrinkage value to other dimension, but for specific this dimension we are providing the asymmetric shrinkage, because we are trying to control this dimension, right or wrong?
Yes.
Within a limit, that's why. And for other dimension we are providing symmetric dimension. Understood?
Yeah.
Okay, now see, what is the way for providing the shrinkage value? So basically we can provide the shrinkage value by the scale body. So scale body is the command. It means, what is the meaning of scale? If we are scaling any type of body, what is the meaning of that? If we are increasing the
ratio.
volume, we are increasing the volume, or we are decreasing the volume of that body, right?
Correct.
Yeah, so basically, for example, we have a component like this, right? We have component like this. If we are increasing this dimension, all the dimension by the 1%, so what is meaning of that? You will get the core and cavity of this block more than this component, more than exact component, right or wrong?
Yes.
Understood? So basically we have to provide the shrinkage value to the CAD model. We have to provide the shrinkage value to the CAD model in order to get the desired component or a desired dimension component, you can say that, right? the core and cavity or the impression of that component will be bigger than the actual body. Understood? I hope you understood about that.
Yes, sir.
Right? So say here see,
Yeah.
for example, here see, this is the image which is showing the asymmetric shrinkage here. See here, for example, here this is the y dimension, right? This is the x dimension here, right? Okay, this is the z dimension. For example, if I am providing the 1% shrinkage, okay, and from this point to this point it is about 200 mm, this, right? From this point to this point it is about 250 mm, for example, just for an example, right? Okay, so basically we need to control this dimension 0.1 plus minus 0.1. What is that mean? What is the limit of this? Tell me. 200 micron, right or wrong?
Yes. Yes,
Okay,
yes.
and again if I'm talking about this plus minus 0.1, 0.1, so what is the limit of this? Again
200 micron.
200 micron. But see here, for example, you can if you provide the uniform shrinkage to the complete body, what will happen here? Tell me, what will happen here about this dimension? Tell me, what is the 1% of the 100 mm?
101.
Okay, 1 mm. So basically you should get this dimension about 99.8 minimum, right or wrong? Or maximum? Maximum how much?
100.1.
100.1. You should get this dimension. No, sorry, 99.9, right?
99.9.
9 and 100.1. So you should get a dimension within this limit. But because of the 1% shrinkage, what you will get? Definitely you will get 99 mm, right?
99.
Yes.
So this is wrong or not? This is wrong.
Yes.
So for you can say that for controlling this dimension within a limit, within a tolerance, you have to provide the asymmetric shrinkage, right or wrong?
Yes.
So as I told you, for the specific dimension, right? This concept is very important, right? For controlling the dimension,
Yes.
Yes.
right? For the specific or for precise dimension, if we are controlling the dimension of any type of component or the specific component, which is very important for the fitment purpose, right? So there we have to use asymmetric shrinkage value. Okay. Similarly, for example, 50 plus minus 0.1. Okay, we need a limit, for example, plus minus 0.2. So what is the limit? 400 micron. Okay, so we can provide the dimension, we can provide the shrinkage value for this dimension. Tell me how much? What is the 1% of the 50? Tell me.
0.5.
0.5, right? 0.5. So we can take asymmetric shrinkage for that also, for that specific dimension, right or wrong?
Right.
Understood? Or now, for example, we have a 10 mm, we have here 10 mm dimension, and for the 10 mm dimension we need plus minus 0.1. So for this we can provide 1% shrinkage, right? For this we can provide the 1%. This is the simple component, you can say that, in which you will get the only 3 dimensions, right? But for example, if you have a specific component, so in which you will get the 100 or the 120 or the 150 dimension in a single part, right or wrong?
Yes.
Okay, this is just for an example, right? For example, you are giving the shrinkage by the scale body. So what is the way of that? See here, shrinkage divided by 100 plus 1. For example, you have a 2% shrinkage for that specific dimension. So how will you provide the shrinkage value? So shrinkage divided by 100, you will get some value. So for example, 0.02 you will get, and plus 1, plus 1. So you have to scale the body by the 1.02, right or wrong?
Yes.
Okay,
Yes.
understood? This is the shrinkage. Understood about the shrinkage? See here.
Yes, sir.
As I told you, for example, we are controlling the dimension from this point to this point. I need, for example, from this point to this point, center to the center, right? I need 50 dimension, right? So after the shrinkage, what we will get? Less than 50 right? So it will fit.
Yes.
It will fit with its female part in a proper way. It will not fit. So that's why we have to provide the asymmetric shrinkage in order to fit the component into that into their mating part. You can say that. I hope you understood about this, right?
Yes. Yes.
This is the basic thing. This is the basic about the shrinkage. So we have discussed about the plastic material as well as we have discussed about the shrinkage value of that. Okay, shrinkage value of that. Understood? Now we have to discuss with the thermoplastic shrinkage chart. Shrinkage chart. See here. Here we have a thermoplastic material. How much material we have here? It is about 1, 2, 3, 4, 5, 6, 7, 8, 9. So basically thermoplastic material, only 9 material exist. Tell me.
No.
So how much material is exist? Tell me. Your answer should be lots of. Right? Lots. Many. Right? See.
Yes.
So depending upon the composition, but this if I am talking about the ABS or the PS or the PA, so basically this is nothing but this is the virgin material. This is the virgin material, and every material has a you can say that has a application or the you can say that any type of properties, right? Chemical or the physical property of any material has. Okay. For example, if I'm talking about the ABS material, so what is the property of ABS material? Tell me, if you know. Depending upon that properties, we have to use the material into that application, where we can use that material. For example, right here. For example, if I'm talking about the tiffins or the bottles, so for making the bottle, for making the tiffins, we have to use this material, PP and the PC material. Why? What is the reason of that? Because this material will not react with the food. Will not react with the food. So this material are the food grade material. Food grade material. And here if I am talking about the property of ABS, ABS means ABS acrylonitrile butadiene styrene. So ABS is the fire resistance material. Fire resistance material. Is it clear? So basically
Yes.
it can be resist the fire, or it can resist the heat, you can say that. So where if we are preparing the component, we are preparing the part which can resist the heat, so basically we have to use the ABS material there, right? Example, automobile component, okay, and ABS and the PS also, no, not PS, or PC material, PC also a fire resistance material, right? So we can use in automobile. Okay, for example, if we are preparing a casing of the drill machine, okay, casing means you can say that this case, so into this armature will be rotate, right or wrong? Because of the electromagnetic power, right?
Yes.
So what will happen there? Because of that, outer case can be heated. Outer case can be heated. So that's why outer case will be made up of ABS material.
Yes.
Right? So where we need heat resistance material, though there we have to use the ABS type of material. So this is the property of that. But this is not a food grade material. So we cannot use for making the toys or making the bottle or the tiffin type component or the household product, right?
Yes.
Understood? This is very important, right? So you should have knowledge about the property also. For example, if you have a customer and customer said, sir, can we use ABS material for the food, for the tiffin or for any type of bottle component? So you have to give the suggestion to the customer that, sir, you should use the PP or the PC material because this is the food grade material, right? We cannot use ABS or other material with that component, right? So you can suggest that. Understood?
Yes.
Yeah, I hope
Yes.
understood, right? PS material. PS material is used for the transparency. Where we use transparency. Where we use a glass type of texture. Glass type of transparency where we use. So where we have to use the PS material, and as well as if we need heat resistance, we can use the PS material also, right? Okay. Now if I'm talking about the PA and the POM. PA also known as nylon. PA also known as nylon. PA means polyamide. Okay. PS means polystyrene. PA means polyamide. Right? Now, PA and the POM, this two material, basically it is used for the for preparing the medical equipments. Medical equipments. Okay? Because why we are using this material for the for preparing the medical equipments or the component? Tell me.
Because this is we can do complex parts in this material.
Nah, because this is very less reaction with the atmosphere, you can say that. Right, that's why. Okay, so for preparing the RO component, for example, you are making the RO. What is the meaning of RO? Purifier, like, है ना? Purifier. So for preparing the component of that RO, you have to customer use PA or the POM material. Okay, PA or the POM material for preparing the solenoid valve. What is the meaning of solenoid? Solenoid for controlling the water flow, which is used for the controlling the water flow, right? Solenoid. So where we
Yeah.
have to use this type of material for preparing the component of solenoid valve, we have to use POM or the PA material, right? So every material has a specific, you can say a specific use depending upon their properties, right?
Properties.
Right.
Yeah.
Now here, as I told you, PP and the PC, which is used for the for preparing the household product. Household product. Okay, or the kitchenware product we can use. PP and the PC material. Okay. One more material is that HDPE and the LDPE. Acha, what is the full form of PC material? First of all, tell me. Polycarbonate. Right. H who is from the costing department? Tell me.
Ishwant and Rushmendra.
Yeah, so you should have knowledge about the material, right? Right or wrong?
Yes, you're having. Yeah,
Yeah.
you're having.
So HDPE, which is the high density polyethylene, LDPE, which is the low density polyethylene, right? Acha, what is the purpose of this? This is the cheap material, you can say that, right? Cheap material, but for this material, we cannot, this material cannot be used for making the household product. Okay. Okay, why? Because it is used for the packaging purpose. Packaging means, for example, if you are designing a container you can say that, or the storage box, right? So for that you have to use HDPE or LDPE material. Okay, acha, what is the purpose for the PVC material? PVC material has a property, it will react very slowly with the atmosphere, and it is rigid material, you can say that. So basically it is used for the construction purpose, right? Construction. Acha,
Yeah, even in automobile also they will use.
yeah, automobile purpose we can use PVC material, right? And so construction purpose, as I told you, for making the pipes, right? Polycap pipes. Okay, T joint or the L joint, like this type of component, we have to use PVC material. So this all are the application. This all are the application depending upon the properties of the materials. Is it clear? Now here you can see that this is the shrinkage value in percentage or in mm. Acha, tell me first of all 1 mm. How much micron in 1 mm? Tell me.
Then like
1000 microns per 1 mm.
And confirm.
Confirm.
Okay, 1000 micron in 1 mm, right? So here you can see that 0.4 to 0.6 percentage. It is the range. It is the range for the ABS material, right? So it means into 1 mm, it will shrink only 4 micron to 6 micron, right or wrong? Right? See,
No,
mm
that
per
is
mm.
400 microns.
No, how 400 micron? 0.4% to
4%
0.6%.
of 1 mm. Okay, okay.
है ना 0.4 to 0.6%. So it is point here, see, है ना, right? So 4 micron to 6 micron in 1 mm, right? 400 micron shrinkage is not possible, right?
Possible, yeah.
Okay,
Yes.
understood.
Yes.
Okay, so for every material you can say that this is the range, but it can be vary depending upon the composition into this. But if we add some material into this plastic material, into this specific material, so basically this percentage or the shrinkage percentage can be changed. For example, if we are adding the some percentage of GF material or the glass fiber material, so basically it can be changed. Is it clear?
Yes.
Okay, understood.
Okay.
Okay,
Yes.
so basically one you should have a question about how much shrinkage we can take, how much shrinkage value depending upon this range or between this range we can take, right? You should ask a question about that, right?
Yes.
So you tell me, if we have a PP material, okay, and it has a shrinkage range 1 to 2 percentage, and if we have a PP material homopolymer, I mean, means virgin material, there is no impurity of other material into this PP, right? So between 1 to 2%, which percentage I can take? Tell me.
1.5.
Why 1.5? Because it is the average value, right? That's why.
We have to decide
Ah.
depending upon the application.
Yes, and what type of shrinkage we have to provide there, right? Symmetric or the asymmetric, depending upon that, because it can shrink like this. It can shrink 1 to 2 percentage, right? Basically, or we don't know about the specific material that how much percentage it can shrink after solidification, or basically it is also dependent upon the uh, cooling speed cooling speed, or you can say that mold temperature or the material quality, right or wrong?
Yes.
So it is also depending upon that parameters also, right? So that specific thing we have to control, we have to control at this is specific thing, it will be controlled by the uh, customer during the production of the component, right?
Yes.
Okay, I hope understood about this. Okay, so for example,